Okay, we're going to do it that way then. All right, no, that's fine then. All right, so within our organization, we've grown a bit, and we grew up with Mikrotik. So this is not a Mikrotik bashing exercise. It's a very good product, but you get to a point where it no longer scales appropriately for you. So that's what we found, and it was solely based on the number of interfaces we were creating with ppp and L2TP, the terminations. That's what was hurting us ultimately at the end of the day. So I'm not bashing Mikrotik by any way, but it is time for us to move on, which is what we are now busy doing. High volumes of traffic, high volumes of users, IPv6 was hurting us, and queuing mechanisms to implement rate limits for subscribers in their different packages. All of those things added together is what was hurting us. We also found that horizontal scaling becomes inefficient. So with a ppp server, if it starts running out of energy, you just bang in another one, it'll start to load balance to that one, bang in another one. And what we were finding is that our entire cabinet was now full of these Mikrotiks, and if you've got them like we were using those direct attached cables, it's a thick bundle of these direct attached cables down the front of your cabinet, which becomes very, very complicated or messy. So that was the one thing. Then with the CCR1s, which is your 1072s, your 1036s, brilliant devices. The next one up from that was the CCR2s, and those just did not work for us. We made certain assumptions initially in the early days that they were drop-in replacements, which they weren't. You had to rebuild them. They could not cope with the volumes, and your ppp sessions and queues do not go into your layer 3 hardware handoff to your switch chip. It's all handled in CPU, and before you know it, you're in trouble. In the one data center, we're running some 9,000 plus subscribers and about 4,500 in the others, and that excludes Cape Town and Durban. So we're talking volumes. So we went with these servers, and the one server we tested can handle all 9,000 at once. That means we eliminate, well, if we're doing 1,500 to 2,000 per Mikrotik, we can get rid of 4 to 5 of these CCRs. And we're pushing them out at 16 gig and 12 gigs, so the volumes are also very, very good. Okay, next slide. So we started off with looking at accel-ppp and NetElastic. NetElastic is a licensed model, so there's money involved there, and we all know what we're like. All the graybeards is like, no money goes out. We do the best with what we've got. And so we stuck down on accel-ppp's. We got ourselves just a small little Intel box as for a proof of concept, and built that out. The stats are there, dual 10 gig card, one to talk to your AS where all your F&Os come in, and one to talk to your core where you route everything out, 16 gig of RAM, CPUs, no hyperthreading. We bombed that in, testing, we added it to the PPPoE farm that we had and had it pick up load. This proved successful. It was handling load, it was handling queues, and throughput was a lot more consistent. Although obviously in your peak times, you do still get your bell curve going through with your high rates. The next step was to decide on a production platform. So what server were we going to use in this production platform? And we chose the Intel S26, which is a 2U 4-slot chassis. Can you just jump to the next slide? Right, just hold it there because we're going to go back again. So you can see here the chassis comes with these 4 nodes. Obviously, it comes with a lot of disk, but disk for us is not important. Memory for us is also less important. What is important for us is CPU, because you've got to handle those queues and you've got to handle those thousands of interfaces and those packets flowing through. So that what becomes important for us is ultimately the CPU. Okay, go back, please. So we chose that model. It's an older model, and we found that it ran out of steam. There were a few problems. We had one of these servers, so we decided we would try it. So ultimately what you can do is each of those sleds you can use as your, you've got 4 servers in one 2U chassis. Very, very nice. It's an older model. Swapping nodes was an issue, because when you slot that chassis in, you have to access it from the back, and we found that there were cabinet design issues with the way the PDUs were often hung. We couldn't get the sleds out. So we have to pull the whole server forward, tilt it, and an elbow goes to the on-off button. And there you drop a good few thousand subscribers. Only happened once though, hey? Come on, you got to admit. But yeah, so, and again, you know, this was in one of the bigger data centers. So what's the option there? Redesign the PDUs? No, not really. That's not going to happen. Pick another data center. So you got to work with what you've got. So we decided that wasn't going to work out too well for us. The other thing was the design of the sled. Put one CPU behind the other. So you've got that airflow going from front to rear, and the heat from the first CPU warmed up the second CPU. So we found that there was like a 15 degree to 20 degree temperature difference between the 2 CPUs. The rear one was running at about 80 degrees. You know, the docs we said, it all said this is okay. It's like, not so much, not so much. So we kind of moved on from there. Jump 2 forward, please. Past the picture and to the next one. Yeah, there we go. We then moved on to 2 of these test gigabyte servers. Their brand name, they've got they're called Penguins. So it's just an Intel box. That's it. Nothing exciting. It's just the ones that we found at the time. There's nothing specific about these servers. You can use anything and scale it however you like. With Pim in his presentation, he had the 3 servers. You choose what fits your requirements, what fits your price, cost, your brackets. This is what we found, and this is what we ultimately settled on. We tested them with defaults that they came with, namely the dual Xeon 2.2 and 64 gig of RAM. It worked fine. Then we decided to upgrade the CPUs because we wanted more users on per server, and that's where we got to the 3 gigahertz Xeons. This gave us a 10% improvement. Every percentage counts. And there you can see the front and the rear on the servers, stock standard. And what we were also using in these, we started off with dual 10 gig NICs, then we went to quad 10 gig NICs, then we've gone to dual SFP 40 gig. So we have 40 gig up and down on each server now. That's kind of where we're sitting. Although, and Ian will elaborate, we are doing some testing. We're seeing some improvements in actually using a 40 gig uplink to route out, and a quad 10 gig talking to your AS where your FNOs terminate. And there are some improvements there which he will get into. Okay, next slide, please. Okay, so power consumption obviously in the data centers becomes another question, because your Mikrotiks draw your smaller ones, not your 1072s, but they draw about 30 watts of power. So that's very economical. Hence, you can throw hundreds of them into a cabinet. But ultimately, as I say, horizontally, it doesn't scale well. You use up all your space in your cab. You've got no room for anything else. And when you get to a problem like you've got too many users, well, that becomes less of an issue. So you need to put where your power is there. Ultimately, what we found is as shown there, the power per throughput was a graph that we were doing. And the Intels, the force-led chassis was slightly heavier, but again, it came down to that we were doing 270 for 15 gig of traffic, which is good. That's fine. Because you've got a lot more users on there now. You're talking thousands of users. The next thing we found is that we can't leave the day-to-day operational side of this with the technical team. We've got to hand it off to your call centers. They've got to be able to troubleshoot this with your clients, because you are not the person, I hope, who ends up facing all these customers all the time. So we've got to make sure that they have a front end to be able to look at, just to see that the user's connected, how long they've been connected, can they see traffic, all of that. And there was a lightweight GUI which gave us the required functionality, and it helps in letting troubleshooting client issues, which is sufficient for what they need to do. If there's a bigger problem than that, then they escalate it up toward us. Support around the accel-ppp product. We won't mention the country. No, we will. So the support comes out of Russia, and what we found with that volunteer support group was very helpful. The turnaround times were very good. They worked closely with us. So we had no issues there. When we found issues, which we did, and I think Ian will dig into that. Right, so he will talk about that further. We found that it was very good. So that's the why and the how, and Ian will get into no, that was the how and the what, the why and the what. Ian will now get into the how. All right, thank you, Ian.
Russell, thank you for that. Can we move on to the next slide, please? Thank you very much. So we've gone through a couple of iterations, as Russell mentioned. We initially started with the small, went bigger and bigger. Started with Debian, but then we moved on to Dev1, which is basically a systemd-less Debian. The only reason for that is the systemd does a lot of messing around with the UDEV environment in Linux. And to get around what systemd does, there's a lot of improvements that's actually on that link that's shared there to get past what systemd does to UDEV. So the easiest part is just to rip systemd out, so install Dev1 and you're rid of systemd. And that actually improves a lot of things. Then, because accel-ppp is using a kernel module that they compile, that you need to compile in, it's not, they're still busy working with the DKMS modules for that. You need to compile the software on server, because it also takes the kernel headers and installs the kernel module into the modules directory, and you load that. It's a very interesting, you can run accel-ppp without this module, the VLAN monitor module, but it improves your usability of the server quite a lot. What it does is it actually listens on an interface, be that a physical interface or a VLAN interface, and if it sees any PPPoE packets coming inside a VLAN, inside that interface, it dynamically creates that VLAN and starts listening on that interface for PPPoE packets. So, I mean, looking at some of the bigger FNOs where they give you an outer tag with 10 million inner tags, you don't have to go and manually add each and every inner tag to your devices to listen for PPPoE. It dynamically allocates that, and as that FNO brings up a new area, it just starts working. You don't have to manually go and add another VLAN. So we found that makes things a lot easier from a management perspective. Then what I've done is internally I've created some Debian packages to make ease of deployment of these servers a lot better. The end goal is so our NOC actually can just install the operating system, install the package, and the server is set up. There's no need for me or Russell to get involved getting the server up and running. In terms of some of the side effects we've had from this, most of the issues we've seen with the accel-ppp software is that it stems from the accel-ppp module, which the developers has actually said that it's not under active development because it's not a sought-after feature. They focus a lot of their development time on the IPOE and the PPPoE modules of the software. And then, quickly, yeah, so and then moving back to the server side of things, as Russell mentioned, we've scaled up our processors quite significantly, going from we started with the 3 gigahertz, dropped down to 2.6, 2.8, and then 3 gigahertz. That's because we found that a higher clock cycle is better in terms of performance than more cores. And I think Pim will also know about this, but the problem with the Linux kernel is how it handles those packets where it responds on an interrupt instead of just handling the packet. And what I found, so just before I go on to that, so what we've also found during our testing phase is we installed the test server alongside the Mikrotiks, the 1036s, and even at the same PADI delay, we were seeing the test server picking up sessions a lot faster than the Mikrotiks, just because it could respond to those packets a lot faster because of the higher clock cycle. And I just want to see. And at that stage, the Mikrotiks was sitting around 1,500 users, so not close to capacity. The server was sitting around 4,500 users, and I had to artificially increase the PADI delay so I don't overload the server, because it was just hungry for these PPPoE sessions. On our side, memory, as you will see on the next slide, is not that big an issue. We don't use a lot of memory on these servers. CPU is the important part, and then the second important part is the disk for the logging. Because one of the things that I like about these accels is you actually get a per user log file. So if there's anything wrong with a user, you can go into that log file and see what went wrong. Why did the user disconnect and the likes? Although in that, with the accel-ppp module again, there's a bug where it actually crashes the system when a certain log entry gets created. So I had to disable file logging on the accel-ppp side of things. Next slide, please. Right, so this is this is a Friday afternoon at 3 p.m. screenshot of the traffic going through the servers. Top leftmost side, that's one of our servers that's currently doing 900 accel-ppp sessions. That's from 2 of the layer 3 FNOs. And then the next 2 is our initial starting POC, which is still running in production, where we've got, you can see down there, 5,000 users on the one and 4,000 users on the other one, with the CPU basically idling at 35%. Keeping in mind that the CPU usage there is an aggregate, is an average of all the cores on the server, all 36 of them. It's a dual core 16, it's a dual socket 16 core processor with hyperthreading turned off with 64 gigs of memory. Memory sitting at 6% and 7% respectively. So there is a discrepancy between the traffic volumes between the two. That's because I had to artificially deprioritize the middlemost one. There's a bit of an issue with the way I installed the operating system, with Debian interfering with a bit of the processing power. Next slide, please. The next slide is the old 2600 servers that we used as the initial tests. So these two are running in Cape Town doing triple PoE sessions. Also looking at the processor and memory usage, it's all running quite nicely, and each of them doing the work of 2 Mikrotiks quite easily. Next slide. Yeah, so some other problems that we've had with this is there is some changes in accel-ppp that you need to restart the service to apply, which obviously takes down 5,000 users at a time. But most of the common settings, you can just issue a reload, which is a hitless thing. Then some of the things that I'm busy testing out is to get more throughput through these guys. So in our DC, I've got a bench of 2 of these Penguin servers, one of them running accel-ppp and the other one running BNG Blaster. And with that, I just basically blast the Penguin, make a few changes, and blast it. Now, in terms of my testing, I've gotten the throughput up to 1.7 million packets per second. I want to break the 2 million packets per second mark. To that effect, so the biggest bottleneck that I found is that due to the lack of entropy in triple PoE, you've basically got a source and destination MAC address, and that's it. That's how it hashes it onto a queue from the network card's perspective. It basically saturates 2 queues, 2 queues, 2 cores, and that's where your speed limit comes in. You've got 2 cores running at 100%, and the rest of the NUMA node sitting at 60%. So that's part of what Rob was also saying. I engaged with the developers, which are Russians, but they're not from Russia. And they were, the advice that they said is to, rather than using a single big pipe, just use many smaller pipes. So that's where the Quad 10 comes in. And with the Quad 10, I've basically got 2 queues per interface. I've got 4 interfaces. That gives me 8 queues instead of 2. And with that, I've actually tested the throughput up to 2.5 million packets per second without doing any additional optimizations. As Russell mentioned, one of these servers we've tested up to 9,000 users. The caveat there is if you're not doing any additional processing with those users. If you're doing natting on this, if you're doing any kind of weird things, firewalling, queuing, then you're going to start seeing some packet loss with 9,000 users. I've tested these servers in production with 6,000 users on a server doing CG natting with NF tables and doing queuing and IPv6 and all of the bells and whistles without any customer complaints of packet loss or throughput issues. With iPerf, I've tested these servers going up to 36 gigabits per second going through the NIC. And the limit there is because we're running a bit of an older generation PCIe. We're running PCIe version 3. And that limits you to about 36 gigabits per second. Some footnotes that I've added there is accel-ppp announced, I think it was in March, that they were bought over by VYOS, which is an open source routing platform. And then the next footnote is just a website for the software. Okay, last slide, and that's the questions. Any questions? Pim, you're not allowed to ask questions.
Hello, my name is Pim. I come from Switzerland. It's not a question. It's actually maybe some advice. Have you ever talked to this guy called Stanislav Zaikin? Also a Russian, not in Russia.
No, I've not.
I'll give you his coordinates. He works on VPP, and he also built a VBNG with a control plane daemon running along the side and all of the data plane stuff in VPP. And he easily does 100 gigs per machine.
Okay.
With PPPoE offloaded to the data plane and the control plane just in a little binary offside. And there's another project that was before that called B-RAS,
I've seen open
but I
BRAS,
think it was abandoned.
Yeah,
Like
that's
last
been
commits is like 8 years or so
Mm-hmm.
ago. So Stanislav is still working on this stuff, and he runs several of these. And he's also active on the VPP developer mailing list.
Okay,
So that may
cool.
help you in your quest for
Oh,
higher
yes, it will.
performance.
Thank you.
And 2 million packets per second, you can do better.
Thank you.
Henrik Versage, Envisage Cloud Solutions. Have you tried virtual functions on those 40 gig interfaces to get more queues out of them?
I've looked at the virtual functions, but I haven't had much success. And what I found on the internet in terms of documentation is quite lacking, in my opinion.
Ed from Zanog. From your comments there about L2TP, are you currently using it for OpenServe sessions or?
Yes, we are currently using it for OpenServe and end-to-end sessions.
Okay. And similar ratios or?
Can we just go back to that first slide with the, yeah, one back. Oh, sorry, a few back, there. So if you look at this, I've actually got a breakdown of how much we're using there. So, no, top, middle one, bottom row. So on these two, we're running 4,000 users, triple PoE. That's split up into, we've got 30 users actually running on L2TP. But if you look on the first one, that's actually doing around 500 L2TP users.
So we haven't swung all of our OS OpenServe over. As I say, this is an ongoing project, so slowly.
So any specific problems you're experiencing with that? No. Okay.
Yeah, so the last problem was that if it receives a certain log entry, it crashes the entire accel-ppp.
What type of log entry out of interest?
I don't know.
Oh, okay. You're not actually seeing the
Because
thing.
it crashes before it logs the entry. but yeah.
Okay, cool.
Hi, Graham from the internet. You were talking about paddies and paddy delays. Are you just manually tuning that, like add a couple of milliseconds, delete a couple of milliseconds or whatever? Or does it support some kind of dynamic adjustment that as it gets heavy, more load, you can dynamically increase your paddies to
Yeah.
kind of stabilize and balance stuff?
Yeah, so what I like about this is you actually have the ability to define a very wide range of paddy delays. You can start out with a paddy delay, and then you can actually start, when it gets to this amount of sessions, set the paddy delay to this. If it gets to this amount of sessions, set the paddy delay to this. And that's an endless setting. So you can set that up just the way you like. And that's what I'm actually doing here is I've got a paddy delay, and then when it gets to, I think, around 3,000, I start artificially implementing paddy delays to balance out. If user starts preferring the one, it'll automatically just move over to the other one.
Cool.
Okay. Thank you.